The topic of this video is determining the inverse of a function. Let's look at a problem. The domain-restricted function f of x equals x squared plus 4 if x is less than or equal to 0 is 1 to 1. Find its inverse. I like this problem because it shows that domain-restricted functions and piecewise defined functions can be 1 to 1 and therefore have inverses. And here's a problem with a domain-restricted function that happens to be 1 to 1, and we're going to find its inverse. Let's go through the 4 steps together. Step 1 is to turn f of x into y. So then we would have y equals x squared plus 4 if x is less than or equal to 0. Notice that we keep our domain restriction with our equation. Step 2, turn all x's into y's and all y's into x's. So then we would have x equals y squared plus 4 if y is less than or equal to 0. Notice that our domain restriction has now become a range restriction. Step 3, solve for y. All right, well, to solve for y is actually fairly easy in this particular problem. We're going to subtract 4 on both sides. This is going to give us x subtract 4 equals y squared if y is less than or equal to 0. I'm going to swap the two sides of our equation and then use the square root property from intermediate algebra. Drop the square and any parentheses, and on the other side put plus or minus square root. So notice that I've now solved for y, but there's one more simplifying step that I'm going to make before I call step 3 done. We notice here that y is equal to plus or minus a principal square root. We call this the principal square root, p for principal, p for positive. So if I temporarily cover up the plus or minus symbol, this principal square root is guaranteed to be a positive because that's part of the definition of principal square root. Then when you apply the plus symbol, it remains positive, but if you apply the minus symbol, it becomes negative. So therefore, y is going to equal a positive or a negative depending on which one of these symbols we choose. However, we have a range restriction which tells us that y must be less than or equal to 0, which means it can be 0 or negative, but it cannot be positive. And for that reason, we can use this restriction to eliminate the plus part of the plus or minus symbol, so that now our equation says y equals negative principal square root of x minus 4. And now that this range restriction has done its job, there's no reason for us to write it anymore. And we have what y equals. All right, now that brings us to step 4, which is to turn y into f inverse of x. And so we get our final answer, f inverse of x is equal to negative principal square root of the difference x subtract 4. Notice that it's possible to start out with a domain restricted function and end with a function that is not domain restricted.